Okay, so today we're going to do the cosine rule. Now, once again, like the sine rule, there's the derivation of it. It's different to the cos ratio. Cos ratio only works in a right angle triangle, whereas the cosine rule or cos rule works in all triangles. Okay, now it's a bit of a strange one. This is it here. A squared equals b squared plus c squared minus 2bc cosine of a. Okay, and that's if you want to find a side, and then a rearrangement of that rule is this one here if you want to find the angle. Now, these letters don't have to always be A, B, and C, all right, but they do have to go in the order of, here's one of the sides, okay, here are the other two, those two sides go here, and that angle goes there. So if I was to rearrange this rule to say b squared, then this would be a squared plus c squared. This would be 2ac, and it would be cosine of b. Okay, so just be aware of that you can change it, but you've got to follow the same pattern. Similarly, if it was c squared, that would be a squared plus b squared minus 2, and these two together, ab, cosine of c. All right? And we can do the same here. Now, you use the cosine rule mostly when you've got two sides and an angle that none of them match. For example, you might have angle A, side B, and side C. Therefore, you can't use the sine rule because you need a matching side and angle to use the sine rule. So let's have a look at an example. Okay. All right, so we've got x, y, z. Now, at this stage, if you were in an exam or question, you wouldn't know that you can't use the sine rule. So I always start with writing down my information. I've got angle x, and I've got side y, and I've got side z. Now you can see there that you don't have any matching. So you don't have an x and an x, a y and a y, or a z and a z. So you can't use the sine rule. So it's an indication that you need to use the cosine rule. All right, so first of all, wants me to find side x. So this would be x squared, then it'd be the other two, y squared plus z squared, minus 2 lots of yz, cosine of x. Okay, so that's just changing my rule to suit my letters. Okay, now I go 2.1. I think it's always good to put them in brackets. And I even put these in brackets, just in case your calculator has a bit of trouble with it. And cosine of 50, making sure that we're in degrees on our calculator. Now you can do this in just one go if you want to. And remember, this is what x squared equals. So we are going to have to find the square root at the end. Okay, so 2.1 squared plus 3.9 squared minus 2 times 2.1 times 3.9 multiplied by cos of 50. Okay, and that gives me 9.09, and then I'm going to do the square root of that. And I'm just going to do that on my calculator so that I get as accurate an answer as I possibly can. Okay, so it's 3.02 centimetres. Okay, now we have to calculate angle y as well. So I'll just go down here, sorry. So we are actually going to use the cosine rule for the angle, okay? And we're going to switch it around a little bit. So we're going to go cos y actually equals x squared plus z squared. It's the other two. Take away y squared divided by 2xz. Okay, so just follow the pattern of where all the letters go. Okay, so now I've got x squared, which x is 3.02, plus, now you've got to be a bit careful with your brackets and things here, all right? That's 3.9 and that's 2.1. 2 times x times z. All right, now what you're going to have to do here, you're basically going to have to bracket the top. If you want to do this in one go, you're going to have to bracket the top and you're going to have to bracket the bottom, because BOMDAS will not do addition before it does division. So you've got to be very careful about that. What I always do, I just do the top line. So I go 3.02 squared plus 3.9 squared minus 2.1 squared, and I get that 19.92. And then I just divide this and I do this in a bracket. That's how I do it. Feel free to work out your own way as long as it's right. Okay, 2 multiplied by 3.02 multiplied by 3.9. It might take a little bit longer, but it's a lot less room for error. Okay, so even though I'm rounding that off, I'm going to leave it on my calculator. Now remember, there's another step here. We've got to inverse cosine it. Okay, so inverse cos of the answer, and that gives me 32.26 degrees. Now, does that make sense? 32.26, let's just make sure that it does. So that one is opposite that. This one here is 3.02, so let's just check out and make sure that these angles are right. I haven't found angle Z, but I can by taking them away. 180, take 32.3, take 50, gives me 97. And that means that that should be the longest side, which it is. And this one is the smallest angle, so that should be the smallest side, which it is. Okay, I'm not going to do the next example. Oh, yes, I will. Okay, I will. I'll do this example on another piece of paper because it is a good one to do. Okay, calculate the largest angle in a triangle with sides of 12, 14, and 20. So you can call these whatever you want. Now, you know that the largest angle will be the one opposite the largest side. So it'll be C. So I'm going to want to find angle C. So I'm going to use my rule, a squared plus b squared minus c squared over 2ab. Okay, and that's going to give me 12 squared plus 14 squared, take 20 squared over 2 times 12 times 14. Okay, once again, I'm going to do that in a bit of a two-step process. I'm going to do the top line, 12 squared plus 14 squared, take 20 squared, which gives me negative 60. And that's fine because sometimes your angle will be bigger than 90, which is why it's negative. We don't do that until year 12, so don't stress too much about that. Okay, 2 times 12 times 14. Okay, that gives us negative 0.18, which we then find the cosine of, or the inverse cos. Inverse cos. So inverse cos of my answer, and that gives me 100.29 degrees. Okay, so don't be worried if you get the negative there, that's fine.